Good evening, and thanks for joining tonight's TI Technology event hosted by Texas Instruments, where tonight we're going to discover some transformational geometry in 15 seconds or less. We'd also like to thank everyone if this is your first time joining us. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to introduce our two panelists for tonight, Judy Hicks and Tom Reardon. Judy, who lives in Colorado, taught high school mathematics for 34 years in the Denver area. As a T-Cube national instructor for TI, she is dedicated to helping other teachers learn how to effectively use educational technology in the teaching and learning of mathematics. Judy has authored numerous textbooks and is active in state and national mathematics organizations. She also received the T-Cube Leadership Award in 2014. Judy, thanks so much for being with us.
Thanks, Mike. Even though I am from Colorado, I happen to be in Atlanta tonight, so enjoying some little hotter weather, but thank you.
And Tom taught at Fitch High School in Austintown, Ohio for 35 years. Tom has served as an adjunct professor at Youngstown State University for the last 34 years. As a T-Cube national instructor, Tom has worked on the development of the TI SmartView emulator software, TI-Nspire CX, as well as the TI-Nspire Navigator. Tom currently works for Texas Instruments in product strategy and development, and is currently working on transformational geometry Lua activities, which I think is perfect for tonight. He also does professional development nationally and internationally. Tom, thanks so much for being with us.
Thanks, Mike. Hello, everybody.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. We'll also send general messages in the chat window. Once we move to the software, that right section of your screen may be replaced with a green floating toolbar. And if that is the case, you can access the Q&A window by clicking the question icon underneath that green floating toolbar. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Once that recording is available, we'd love for you to follow along with the recording and not try to follow along step by step tonight, especially as many of the files that Tom and Judy are going to be using tonight are pre-built. And so the best thing to do is really download that recording and then go through it at your own pace. That way you can really focus tonight on just asking questions, getting questions answered, and enjoy the presentation tonight. We hope you don't have any audio issues, but in the event that you do, try one of two things. First, at the top of the WebEx menu, try choosing Communicate, and then click on Audio Broadcast. If that doesn't work, in the participant window where your name is located, in the lower left-hand corner of that window is a phone icon. If you click on that phone icon, if you're having audio issues, it will allow you to call in using your phone as opposed to using your computer's built-in microphone, and that should solve any potential audio issues that you have tonight. At this point, Judy is going to discuss our agenda.
Thanks, Mike. All right, even though tonight is going to be primarily about some of these new activities that Mike referenced of learning things or discovering things in 15 seconds or less, or at least being exposed to them, we are going to just talk about transformational geometry in a lot of different ways. So, such as, we're going to look at MathDraw. We're going to, again, focus on those 15-second or less activities that will hopefully let students discover and develop concepts, and also talk about how transformational geometry does align with the standards, and then if there's time to show a few other activities that are on mathinspire.com. And we'll hopefully have some time to look at other online resources, and then there will be a webinar giveaway.
Thanks so much, Judy. And Tom is going to discuss our expected outcomes.
And so tonight we're going to look at how software can be used to introduce a topic like transformational geometry. The files that we'll be looking at tonight can be used on handheld, TI-Nspire handheld, software, and iPad app. Also understand how students can PIDE properties. PIDE stands for, what does it stand for? Play, investigate, explore, discover. Play, investigate, explore, discover. And we're going to see how you can do that in all 4 different types of transformations and how you can find activities on Math-Inspired.
Thanks so much, Tom. Judy, it is all yours. Feel free to share your desktop.
All right. Thanks. Now, while I'm getting my desktop squared away here, what I'd like for people to chat, if they would, is how do you introduce transformational geometry now in your classroom? So just chat that just in a couple of words if you can. And we'll take a look at that. So please chat that.
Hey, Judy.
Yes.
So I know at least for me, my background is not in a lot of geometry, but can you give me some examples of what transformational geometry could be? Refresh my memory.
Okay, well, we're talking about, and again, and Tom's going to talk about this a little bit more about translations, rotations, dilations, those kind of things. So we're starting to hear some things now from people: paper folding, mirrors, patty paper, GeoGebra, dynamic geometry, great from Chuck, graphing paper foldable. So hopefully you're seeing all of this that's coming in. And so that's kind of the intent of tonight, is just to show you other things that you can do and to introduce or to review or to, again, all the different things. And these are all great manipulatives, so to speak, some of you are doing. And so very quickly, what I wanted to show is something on TI-Nspire that a lot of people either forget that it exists or they don't know that it exists. So right now, I'm going to go up here, even though I have a new one. I'm going to go up here and do a new TI-Nspire document, and I'm going to add a geometry page. Now, the idea with this is not to show you everything with this, but I would really encourage you to look at this, because this is kind of a nice feature. This is a feature, though, that only works on the software. So this would be a nice thing to be able to have students maybe come up to your computer, or if you have an interactive whiteboard, or if you happen to have, if you happen to be in a school that has student software. So this does not work on the handhelds. So what I'm going to do is I'm going to go to Menu, and then Actions, and then down there at the bottom is Math Draw. And this was, I forget which OS this came about, but now this is a little bit harder for me to do with my mouse, but like I said, it's really nice on an interactive whiteboard. But if I look up here in my tooltip in the corner, you can see where it says to draw certain geometric objects using mouth gestures. And so what I'm going to do is I am just going to try to sketch a triangle, and as soon as it gets to what it thinks, you know, it recognizes, and it doesn't recognize everything, but it recognizes a lot. So, and then now I'm going to take and make a very crooked line. So that's pretty cool. And now so this could be a way even that you introduce kids to transformational geometry, because now, and it wouldn't have had to have been a triangle, but I'm going to now go to Menu and then Transformation. And again, we've got a lot of things that we can look at here, but I'm going to choose Reflection. And then I have to click on my triangle and then click what I want to do on, oh, thank you, Art. Yes, it does work on the iPad as well. And so it's a nice way to kind of get kids talking about vocabulary, you know, and just a real quick thing. Now, there are other things that MathDraw does, but we just thought that this would be kind of a good way that sort of a manipulative, but a little bit higher up, I guess, if you want to think about as far as the technology goes. So now what I'm going to do, and thank you for all chatting all the different things that you did. And yeah, Chuck, that's a great comment there. It is good to see that the labeling was done correctly and immediately. So that's another thing that we could do with kids too, but I'm going to kind of let Tom talk about this. But of course, as I move stuff around and drag the vertices or drag my line of reflection. But again, Tom is going to talk about this a little bit more. So now, Tom, I'm going to turn it over to you. And you ready, Tom?
Yeah, ready.
All right. And I'll be back.
Okay, so this is reflections. We're going to look at reflections. These activities, I'll warn you, are still in development, but should be completed this summer. Of course, I did that last school year, and it wasn't not last school year either, but dilations and reflections are completely finished and are on the Math-Inspired website, which we'll look at a little bit later, under Geometry and then Transformational Geometry. Translations is about 90% finished, and rotations just came out to be about 70% complete, okay? The activities consist of TNS files, student sheets, and teacher notes in one lesson bundle. But let's just first showcase reflections. Let's get into the math. So I'm going to go ahead and use the handheld first, and then I'll use the software a little bit later. And I'd really like to use this on the iPad app, as some people have said too. So control right arrow to get to the second page, and this is just a page to kind of set the tone for what students should understand about reflection soon. Go to the next page, and this really isn't part of the have to be part of the document, but this picture just fits so well I had to put it in here, especially since we can put photos in Inspired documents. But page 1.4 is where all the magic happens. So we want to reflect triangle ABC about this horizontal dashed pink line. And to do this, you can click on the icons that are there, but we also have some shortcut keys that we're encouraging. And the shortcut key for reflection is R. We're hoping that might make sense. So I'll just tap R, and it reflects a triangle about that line. And we just want students to start to understand what that means by being a reflection. We want to investigate, because we only have one triangle there. So maybe if I touch C, the letter C, I can now use the up, down, left, right arrow keys to look and investigate other triangles. And this is what I was talking about play, investigate, explore, discover. Just turn students loose. Say, try moving point A, try moving point B, and watch what happens. You can even move the whole shape if you press the letter S and see what goes on there. We couldn't use T for triangle because it was also used for translation. So while moving the points, we're hoping students make observations. Things at the beginning we'd like to hear are mirror image, flip, reflect. Maybe corresponding sides have the same length, corresponding angles seem to have the same measures, triangles appear to be congruent, and so on. So let's go ahead and change the line of reflection. So to do that, up here at the top we have a place where you can change that. But we went with H to be horizontal and I to be vertical. So I tapped the line I, and immediately we have a vertical line. And now I'm investigating how the triangle looks like when it's reflected about a vertical line. And then for slanted, the line Y equals X, which we'll look at when we get to a grid, I press the letter J. So HIJ, horizontal, vertical, slanted, and I can now go ahead and investigate, what happens when you reflect about different lines in the plane. So right now, that's like the very first thing we'd want them to do, just get a feel what we mean by a reflection. Nothing real heavy or deep here, but a lot of time to play. So we're going to use one of the several pre-made templates to quicken the setup. So I'm going to press the menu button, and there's several templates. I'll press number 1 or enter, and these are all the different things that I can go with. So I'm just going to go with number 1, connected segments, and see what that does. And it restarts or resets the screen to the original. And we're going to go ahead and explore. So again, I'll reflect about this. And how is this different than was before? You'll notice those dashed segments connecting corresponding vertices. And so I'm going to pull point C up so that one triangle is in one half plane and its pre-image is on the other half plane. And we'd like to start them to discover what seems to be true about those dashed lines. And just let them, again, play and explore. Let them just play around with the mathematics, play around with the geometry. And what we're hoping they discover is that these dashed segments are perpendicular to the line of reflection. They're parallel to each other. And those points, T, S, and U, seem to be midpoints, okay? But that's for only vertical lines, horizontal lines. So let me try vertical lines and see if that seems to be true. So again, let me grab point C so this is a little bit clearer, and maybe point A, pull that around a little bit, okay? It seems that those black dotted lines are perpendicular and those points are midpoints, and then we'll try, of course, some kind of slanted line and be able to play, investigate, explore, discover that as well. Again, I could move the triangle by using the shape. And what we're hoping is that students will start to form conjectures about what they're observing, and we'd like to have them confirm or disprove their conjectures. So I'm going to go back to menu, and I'm going to use a different template. This time I'm going to use the one called distance to reflection line. And you can see there's a little bit different here, okay? So I'm going to pull point C up before we get started just to make it a little bit cleaner looking. And then I'm going to reflect with the letter R as the hotkey or the shortcut key for that. And now it's starting to give me these distances. SA and SA prime are both 4 and so on. And again, investigate other triangles, not just one triangle, and look at what's happening there. And then grab point B, grab point C, and then start to investigate different lines as well. Now, we're only looking horizontal and vertical and just one slanted line, so maybe I could go back to the menu and change the reflection method so that it's a movable line. And again, I'm going to put point C over to the side. Now, this line may be y equals x. It may not be. It doesn't matter. It's just some line that isn't horizontal or vertical. And I'm going to go ahead and reflect. And notice it's giving me those distances again, SA and SA prime, TB and TB prime, and so on, to show me that, yeah, they are seem to be equally spaced from that reflection line. To move the line, I'm going to grab either point P or point K and move that about, and now I can move the line to different places, and I can still see the reflection thing going on. Or I can grab the whole line by pressing the letter L and let the line slide up and down, and students again can think about what's going on. Grab point K, make it horizontal, and so on. So I do like the movable line issue. Now, I talked about those being midpoints, and I think that's pretty sure, but I haven't talked about those being perpendicular. And you'll notice on the screen it has next. That's the next set of data. The shortcut key for that is the right parentheses, kind of like a greater than sign. And here, it's measuring the angles ASU, BTU, and so on. And again, I can go ahead and move the points and also move the line. And students can see that, yep, that perpendicular thing seems to be true all the time. Right, so at this point, it might be a good idea. Let me stop and see if we have any questions. Judy, has anything popped up on the chat? People want to know anything special? Is anybody listening?
Sorry, Tom. I
That's
was
okay.
muted. Yeah, people, let's see, I'm just going back, and Mark is commenting that some of these things can be done, because I think there was a question about the 84, and do constructions on the 84 to do all the transformations,
Okay. So,
which is done through Kabir Jr.
mm-hmm.
And there was a question from Shelley. Does the software, and I'll let you answer this, allow for reflection of a reflection?
So reflection of a reflection?
Yeah.
No, at this point right now, it will not do that.
Okay, I didn't think so.
Yeah.
But
okay.
I wasn't, yeah.
All right, so let me go ahead and continue on here and show some other things. So this time I'm going to press menu, and some of you are probably saying, where's the grid? You know, there should be a grid here, and I learned from the experts that that's not necessarily true, that you don't start with the grid, you don't start really with any measurements, you let them kind of discover what a reflection is without anything else kind of messing up the things here. So here we have a triangle on a grid, and we're going to reflect it about the line y equals 0, or the x-axis. Again, so when I reflect it, it shows me the coordinates immediately of those points. And again, I can start to look for patterns, and most of you or all of you probably know what the pattern is. But just to let you see that, what happens when you change the x-coordinates, of course, stay the same, and the y-coordinates are opposites of each other. Now that's when you go about the x-axis. If I want to change the equation, I'll press the equal sign, and it opens up, oh, I'm sorry, on the grid without the equation, sorry. So I can just press the I button to go to vertical line and see what patterns goes there, and J for the line y equals x, and look for the patterns there. But we wanted to take this a little bit further, so we changed the menu so that you can have a template where it shows the equation, and you can have the equation of any line be typed in. It doesn't have to be the big 3 that we've always done. So here again, we've got y equals 0, and I'll reflect that. But if I want to change the equation, I guess press the equal sign. I was in the wrong spot before, sorry. And these are our options for what we can see. We can have any equation in the form y equals mx plus b, x equals any constant, and y equals any constant, and reflect about those lines. So for here, if I wanted to reflect about, let's say, the line x equals 2, I could just go ahead and type in x equals 2 and press enter, and then talk about what happens to the coordinates there. And for that one, it's a little bit more algebraic than we would do maybe at a middle school or maybe even in a high school geometry class, but there's some interesting patterns there that you can talk about. If you want to see more of them, you can check out the activities that we have. One of my favorite lines to find the reflect about is the line y equals negative x. So I'm going to go ahead and look at this equation y equals mx plus b, and tab over here and go with -1 for the coefficient of x plus 0. And you'll notice the coordinates there are interesting. It's not something that's probably in the, quote, Common Core or whatever, but I still think it's definitely worth a peek at going ahead and investigating what happens to the coordinates as you reflect over the line y equals the opposite of x. All right, another thing we want to talk about is the students might start talking about the angles, measures, and so on. So I'm going to go back to menu and go to number 1 and look at angles and sides, the number 3. And this is, again, without a grid, though I could put a grid in if I wanted to. But I'm going to go ahead and reflect about that line. And you can see it measures the angles immediately for us. Again, one triangle doesn't make a conjecture, that's for sure. But as I go along here, it definitely looks like the certain angles are equal. And one of the things that we put in the directions into the activities were that a lot of students we found would say things like all the angles are equal, and we definitely don't want to let that slide. the word corresponding needs to get into their vocabulary, and we stress that in there. We want to talk about the corresponding sides being equal, so I'll press to see the next set of data, and it shows me the corresponding sides being measured instantly as we change the triangle. And I noticed that some of you said that you're doing these things with GeoGebra or Geometry Sketchpad, and that's great. I think most of these could be done with that. I'm not sure all of them can. But the trick is that you have to create them, or your students have to create them, and this takes a long time. And so what we're trying to do is create these so that your work is minimal, and most of the students' work is, or time is spent investigating, exploring, discovering, and not, set up the triangle, measure each angle, set up the line, reflect, and so on. All right, so what about documents that help with these? Let me go ahead and show you the teacher document. Okay, I have a tool on that I don't want. There we go. All right, so here are, these are available, will be available online, okay, the reflection ones are. The very first one are the teacher notes. I want to point that out. They're quite extensive, but we think they're very important. The first page is pretty much a open letter from the developers to the teachers explaining, how these were developed and why they were developed and the advantages to them. Page 2 is pretty much a real quick description of each lesson. The Reflections has 10 different lessons. The first one is always the tour, and we suggest we pretty much mandate you do that first. It kind of shows you what a reflection is and also how to use the technology. And you can pretty much do these in almost any order. All of them include a self-assessment and usually a compass construction as well. Third page talks about math objectives and vocabulary that your students need to have throughout these lessons. And page 4 was added just recently, suggested lesson plans. There was some talk about, should we really do this? Teachers are going to do what they want, and we suggest, and we understand that. But after field testing this across the United States, we found that these ideas work best. There's sometimes a good idea to do things orally with the kids, sometimes just let them do it in groups, sometimes let them read the directions and discover. And one thing that we found out for sure is students don't read directions, and if they do, they don't follow them. That's just human nature, I guess. That may be only an Ohio thing. I'm not sure. Let me know in the chat window if that happens in other places too. And then page 5 starts the actual lesson bundle where the lesson 0 is Reflections Tour. And this is pretty much the students get, but we also supply the answers. We apply questions to ask your students. We just try to make it so it's very easy for you to use and not have to do a whole lot of thinking, but be able to work with your students and have good questions to ask and good answers to supply. All right, for lesson 6, I would like to show one of the lessons, lesson 6. One of the things we really are encouraging is having students do things by hand. Even though we have this great state-of-the-art technology and you can see it, I don't think they really get it until they actually reflect a triangle by hand. So we have this lesson here has them reflect about the x-axis, then there's one to reflect about the y-axis, and then of course one about y equals x, and then we go on and on other lines as well. And if students can do it on their own, that's great. Most students can. But if they can't, I'm going to go to the software now, and this is Reflections Lesson 6. And this was written with what we call step-by-steps. So this looks just like the PDF we had. And here, so here we're here, so how would you reflect this about the line y equals 0? If they really don't know how, if they just click on the arrows here, it'll take them through step by step. So watch what happens here. So I'll click the first thing it says, through D, make a line perpendicular to y equals 0. If they aren't sure what that looks like, click again. Then it says count the number of units from D to y equals 0, shows it, and counts them. Count the same numbers but in the opposite direction. So it's really taking them through step by step to see how to reflect about the line y equals 0. And then I'll just go through this kind of quickly. It's the same procedure, just using different points. And then finally going through F and seeing that that's 2 units away. And then it draws the triangle, and it shows the connected segments, and also this is the pre-image, this is the image, to kind of just set the tone here. Most students we found can do this by hand, but they needed some help. We have this so that they can work at their own pace. It's like having a teacher with them next to them. Also on each one of these is a self-assessment, and this is the example of self-assessment for reflections. A lot, again, sketches. You know, how would you reflect this about the x-axis? You see the overlapping, a little bit difficult for some students. If the measure of angle A is 35, then the measure of angle what would be equal to what? Hopefully they'd say measure of angle A prime is also 35 degrees, and so on. Talks about coordinates, perimeters, areas, things that were discussed in all of the lessons before this. And, of course, all those have the answers in the teacher notes. The last one is about performing transformations with compass and straight edge. We're encouraging that as well, and it's an option. And I think it makes much more sense after they've done this with technology. All right, so from that, I'd like to now take you to translations. And for this one, I'm going to go ahead and look at the software. So let me open up the translations document. This is not completely finished, but it's, I'd say, 90% done. And I'd like to maybe get a chat here going after I demonstrate this, because there's a kind of division in mathematics of how you should start this. Right now, I'm going to go ahead and translate triangle ABC about this vector. And to do that, I'm just going to go ahead and press the letter T for translate. And you kind of see what happens there. And again, I can grab point B and move it around on the handheld and grab point A and so on and see what's happening. I can also grab point D and move the vector and see what happens there as well. And then one of the things I like to do also is to grab point W and pull that and put it onto point B and show how that it points to from the pre-image to the image. And not only for that, but along each point along it. And then bringing in the idea about these connected segments so that the students can see as I move this, you know, what's happening here. It looks like a 3D figure, and I appreciate that, moving the triangles and so on. And then going back and testing this and seeing that they're equally spaced, and also that they would discover that all 3 of these dotted segments would be parallel, the same length, and also the same length as this vector WV and parallel to that. These are all parts of the activities in translations. Doing this first, I think, really gets the idea about a slide, okay, how this is a slide from one to the other, okay? But the other way is that we could go ahead and look at menu and use the translation mode that's directional, and then use a grid. And I'm curious which one you think should be done with your students or what you would prefer to do. So this one here, I want to translate this triangle. Let's say I want to move up 2 units and to the left 3 units, and then translate. And look at what happened with the coordinates, grab point A, and see how that happens as I change, what happens to the coordinates, what happens to the shape of the figure, corresponding sides, corresponding angles, and so on. Is this the way to start, or should it be a vector approach? That's kind of the question, and I found people to be very evenly divided on that. So if Judy or Mike could look at the chat window for me and tell me if there's any responses.
Hey, Tom. So
Yes.
First, it looks like that we have a lot of positive things coming from a lot of people that are really excited about this. And Janie said that she loves that you can drag the vector. And Shelly said that we discussed this workshop at the NCTM conference. Although I was initially against the vector, I now feel it's a stronger connection to slide.
Okay.
Tammy says she prefers the coordinate system. And Chuck wanted to add the resultant vector here. Can you add the resultant vector here? It was from Chuck.
Yes, and he's got it. So yes, it is an option. In fact, I'm glad he asked that. In fact, for asking that question, Chuck, you get the virtual Pez. Thank you for asking that. And other people who contributed, I will send you a virtual Pez as well. But yeah, here we have this option menu, and you don't have to go with the menu of what we set up. You can create your own options. So if you want to look at perimeters and areas or whatever it may be, you can pick whatever things you want, and it'll be there and say done. And now when you go through the next menu, you can say, here are the slopes of sides, show that they're parallel. Here are the coordinates. Here are the lengths of those connected segments, and no matter what, those seem to be the same length unless I change the vector length, okay? So anything else, Mike, that I should need to address? Or
Tina asked, what if you wrote up 2 and 3 in that order? What if you wrote up 2 and left 3, sorry, in that order?
Okay, so up 2 and left 3 in that order, like that, and then translate. And one of the things we are going to change is instead of the left being on top and the up being on the bottom, we're going to switch the order of those because then it'll look like slope. So it'll be rise over run, and it'll match when we talk about the slopes of the sides. So for right here, if I show the slopes of the sides, it has everything to do with the coordinates and up, left, right, and so on. Not of the sides, I'm sorry, the connected sides. Let me do that again. Slopes of the connected segments. There we go. So all right, the last one I want to share, and by the way, translations will have the same things that Reflections had. It'll have about 9 or 10 different activities. There'll be a culmination activity, a student assessment, self-assessment. There'll be one with compass and straight edge. They'll all be there, okay? But the last one to share with you is rotations. And rotations is not as far done as we'd like it to be, but there are only 3 people in the world that have seen what you're going to see now because we just got it out Monday. I do want to thank a couple people. I'm thinking about it. Judy Hicks has been definitely helping with developing the activities, and Steve West has been helping with the concepts of geometry with me, and I got to thank them. So I just shout out to them. There have been numerous other people who have helped, but those 2 I got to definitely mention. All right, so here for rotations. We want to go ahead and rotate. Notice the degree measure for the default is not 90 degrees, okay? So I'm going to go ahead and rotate by 45, and I'm still going to use the software here. So rotate 45 degrees, then another 45, then another 45, and this is kind of accumulating it. I'm going to reset that and then show some options about showing the previous image so that when I rotate about point P45 and another 45 and another 45, I can see where it came from before. So there's the 45 from there, but from the first pre-image to the last one, it was 135. And then some people really like this one where you can show historical images, and so when you go around, you can see them all. So some people really like that. But one of my favorite things to do is I'd like students to be able to rotate things by hand. And so what we've done with students, we'll say, all right, I'm going to go ahead and rotate this 45 and another 45 and another 45. How would you do this by hand? And almost always they tell me they have no idea. It's magic. It's just they have no idea. And I can appreciate that. So we put some things in here to try to help them see that. And so there's this menu here. It's called the multiple menu. So I'm going to click on the first option, and you'll notice it's showing arcs. And then the next thing is it shows that these are really going around concentric circles. And the last one shows the arcs are really going along the on the concentric circles. And after they see this, about 30 seconds later, a lot of students will just say, give me a compass and a protractor, I think I can do this. And that's exactly what we want. We don't want to have to show them, we want them to discover. Another thing that Cameron, one of the developers, came up with is if I grab this point, look how cool this is, it shows you where you can go to be able to rotate. It kind of shows you equally spaced things, and that's just, to me, really cool. But I might be the only one. Grabbing that also, you can use the left and down arrows to make the angle smaller and the up and right arrows to make it bigger. And I'm going to do one more thing before I turn this back over to Judy. And I do have to show the grid because I'm sure some of you are saying, where's the grid? We only do the grid. And the reason you probably only do the grid is it's really hard to do transformations without a grid because it's hard to do this. But with this technology, I think it's going to be a lot easier. Here are your options for the angles. We hope that those are sufficient for you. So I'll go with 90. And I'm going to rotate triangle ABC about point P, 90 degrees. And you can see the pattern there with the coordinates. And then again, I can grab the vertices and investigate many, many others. And then go ahead with another to 180. So I can grab here to go to 180. And I love doing this, especially on the iPad. I can feel the math through my fingertips when I touch this point and bring it over to here. Again, another pattern and so on. And so here we have the 270, and then finally the 360, which is back at the beginning. One last one is if I go 60 degrees, what happens if we move point P, change the point of that we rotate about, and now we don't have that coordinate thing going on anymore. And then a lot of people like to put the point on one of the vertices and watch what happens that goes there. And you can do that and then change the triangles and investigate and explore and discover. So this is still in development. We think it's going to have about as many activities as the other. Again, they are on the website right now. This is TI's website. Here's reflections and here's dilations. And if you go there, it has the whole bundle, all the lessons, and you can get them all in one. And then also I have a website that Mike is going to share with you that has the latest versions of rotations and translations. These are already online, but these are not. So if you're interested in playing with these, go there and get them. I would wait about 10 minutes after because I forgot to update this one because they just came out yesterday. If we have questions, time for questions later, I'll answer them, but I want to give Judy a chance to talk about dilations and some other activities. So, Judy, are you ready?
I'm ready.
Okay, there we go.
Okay, as Tom said, I'm just going to show dilations just a little bit because pretty much the nice thing about all of these activities is that they all work the same. Of course, the mathematics is different, but as far as maneuvering, and that's another reason why we always suggest that when they start off on this, that they do the tour first. Because once they do the tour, then they know how to move things around, they know how to get to the different options, and so forth. So I'm going to quickly go through this, and then I'll remind everybody again where this came from, and also take a look at some of the other activities for transformational geometry. Because I do want to talk about some of the things that were in the chat. Allison mentioned a game called Entrapment, which she has her students do with a grid, and she said if this software could do something with that, and I don't know the answer to that without knowing more about that game. So Allison, if you want to chat more about that. And someone also talked about that that they use rigid transformations as a precursor to congruence. And that's absolutely true. And these activities, and Tom showed you a quick look at the student activities and the teacher activities, or the teacher notes rather, and we talk about congruence, and that's kind of where the teacher can take it from there too. Because again, we want these activities to be able to be used in probably starting at 7th, 8th grade, and these are all aligned to the TEKS as well as the Common Core. And depending on whether you're teaching 10th grade geometry or 8th grade or whatever, you should be able to use these activities in one way or another. So anyway, very quickly about dilations is, and again, I know that Tom showed you some of these things. We always like to start off with a screen that looks something like this, and we encourage the kids to kind of play around with this a little bit as to what can be moved, what, you know, what's going on. And again, depending on where you're at in your curriculum, all of these things could introduce vocabulary and what happens if I line things up and all of those other things that kind of go along with this. Now, while we're talking about dilations, though, one thing that I would like you all to chat, and actually one person did ahead, is what other topics could dilations lead to? Or those topics lead into dilations sometimes. So if you could just chat that real quick. All right, we got similarity coming in. And I think that's probably a big one for sure. Anything else anybody thinks of? Direct variation, art, vanishing point, awesome. And this particular activity will be able to show some of that as well. So kind of keep all of those things in mind too, that, you know, these files can be used in a lot of different ways. So once again, when I go to the next page, and again, I can either click on this icon here to dilate, or I can use D for dilate. Right now, my default is a scale factor of 2, but you can see all the different scale factors there that we can use. We do, because that we do have zooming in and zooming out, which, you know, probably could apply to dilations a little bit more. But if I just click on this, and then I can, again, zoom in, I can either with my mouse, or I can just click, I can choose point P over here on my keypad, and now I can start to, and again, just as Tom said, we have student activities, teacher notes to go with all of this. So we can look at, you know, what's equal here, what are the relationships, and here again, I can either go over to the menu and go to templates, and I can look at all of those things, just like Tom showed earlier. But this time, some of these things are, of course, going to look a little bit different. So if I just want to choose angles and sides, then I can start to look at and dilate again. So I can see that my angles are equal. And in the student activity, we ask kids to do some, you know, some recording and say, okay, what happens if what is the relationship? So we have them go through, we have them move things around, record some things and say, okay, what do you think the relationship is? Now, a lot of kids, since these numbers are not real nice numbers, they may not see some of those relationships. So that is also built into this, and we'll get to that in just a second. There we go. So after we have them look at, then we ask them questions like, all right, where did this 2 come from, as an example. So again, all of those kinds of things that we can do. And we can choose what we want to here. And I'm going to go ahead and choose perimeters and areas. But do notice that I can also, I'm going to go ahead and choose these 2 now since we want to make sure our time's okay. And now as I start to go through this, and again, whether I'm not doing too much with changing the scale factor, but I could. And again, move things around a little bit to make it a little bit clearer. And now as I go through, in the student activity sheet, we're asking kids what they're seeing here. And now at some point, is that all right? Well, now we see that the ratio of the perimeters is 0.5. Well, where did 0.5 come from? And again, all of those kinds of questions that we do. And here, now this one's a little bit harder, especially for some kids to see. So we can also, and again, in the activity, we can see that, you know, we ask kids these questions about what's happening here. So all of those great things that you want kids to be able to do, and like I said, we can click, we can go to the grid, pretty much all the same kinds of things that Tom showed you before. And here we're looking at relationship with the scale factor. We can do the coordinates, and so I'm just quickly going through all of that. Now, just to reiterate where these activities came from or where you can get them now besides on Tom's bit.ly. But if you go to education.ti.com and again go into Math Inspired and go to geometry. And for those of you that are not as familiar with Math Inspired, notice that over here on the left-hand side, so I got this from Activities, Math Inspired. And for those of you that are 84 folks, there is an 84 Activity Central. And if we have any science teachers, there's Science Inspired and lots of things there. There's just stuff being added all the time. But there's algebra, geometry, and so forth. So I'm going to quickly go down to transformational geometry. And this is where Tom was talking about. So if I click on this, it takes me to all the lessons, to the TNS file, and as we talked about before, we have some self-assessments, some compass and straight edge type of activities. And you can, of course, either download them all as a zip, or you can download what you want. And again, everything is right there. But before we leave this, and I turn this back over to Mike, I did want to point out is that there are other activities on here. So if you know, maybe perhaps you want to start off, oh, I love Mark's comment, home sweet home. Maybe you want to start off with these activities, and as Tom said, there's only 2 of them right now, but the other ones hopefully will be coming. This hopefully definitely before school starts. But as you can see, there's lots of other activities here on transformational geometry, and many of these talk about the whole idea of congruence and using rigid transformations for that. And again, I would encourage you to take a look at these activities as well. You know, some of them have been around for a while, but I don't think the math has changed. So I think we're okay on that part. So please, you know, take a look at those things too. Okay, Mike, I am going to turn it back to you to finish up.
Thanks so much.
Okay.
As we begin wrapping things up tonight, if you have any last-minute questions for Judy or Tom, please try to get those asked. I know they'll do their best to get those questions answered. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, so we really hope you share your thoughts in the post-webinar survey. We also have another webinar coming up next Tuesday night. It will be the last webinar in our spring series, and it's going to focus on coding. I'm sorry, I lied. That was recently. Next week's webinar is not going to focus on coding. It's going to help give you some ideas as to some things you might consider this summer, so some reading that you might want to catch up on some of the hot books and topics that are being discussed in education. So next week is going to focus on sort of getting you prepared for summer, which I'm looking forward to. Currently, registration is open for our T-Cubed Summer Professional Development Workshops, and we're really excited because there's over 50 different workshops being offered across the United States in many different specific areas. Maybe you're looking to learn more about transformational geometry and using TI-Nspire. Maybe you're, again, looking to improve your TI-84 use, or looking to learn more about coding or STEM, or the new TI Innovator. All of these products have a summer workshop attached to it somewhere across the United States, and with over 50 different workshops being offered, there's a good chance that there's something close by to you that would be of interest. So please feel free to visit our website to learn more. And tonight's lucky winner to receive a complimentary registration to a summer professional development workshop is Michael Holst. So Michael, congratulations. We really hope to see you there as well as everyone else. And Tom, do you have any thoughts about your experience with summer professional development from Texas Instruments, or any thoughts that you wanted to share?
Yeah, I have really strong feelings about that. Back in 1993, I went to Ohio State University for my first week-long it wasn't even called T-Cube back then, and it definitely changed my life, and I did not plan it. I went there with the idea that this was a fad, and I'll try it, but I don't think it's going to work, and it definitely changed my life. And got to meet people like Judy, and Chuck Bondurant was one of my instructors also back in the late 90s, and so hello to Chuck. And I can't speak highly enough about T-Cube workshops.
Thanks, Tom. And Judy, anything that you want to add to that?
Well, I kind of feel the same way. The workshops are just awesome. And this summer, the ones being offered are very different, I think, than what we've had in the past. We still have some of our getting started and so forth, but there's quite a few workshops on STEM. There's several on coding and the new Innovator product, and then some things like productive struggle and teaching strategies. So there's a wide variety this summer. So take a look at them.
Yeah, I like the fact that you get the technology with your registration. So with the registration cost, you'll wind up receiving the technology for that particular workshop. So for instance, if you're attending a TI-Nspire workshop, you'll receive a TI-Nspire and the software. If you're attending a TI-84 workshop, you receive a TI-84 CE and the software. If you're attending an Innovator workshop, you're going to receive the Innovator. So not only do you receive the technology, but you also get the chance to learn from people like Tom, Judy, Chuck Bondurant, and these folks have a lot of experience in the classroom teaching math education with using technology. So it's really awesome to learn from these folks. So please take advantage of that. We really hope to see you at T-Cube Summer Professional Development Workshop. To receive a certificate of attendance, go ahead and click that link in the chat window. Also listed is a link for the documents that Tom and Judy used tonight. And if either of these links happen to not be working for you right now, don't worry, you'll automatically get a follow-up email in a couple days. And that follow-up email will contain a link to the recording, a link to the documents, as well as a link to the certificate. And if you're watching this on demand, go ahead and copy that link down to your favorite browser to receive your certificate. We tried hard tonight to answer a lot of the questions that were being asked, but if there's still any lingering questions that we didn't have a chance to answer, feel free to give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. We'd love to hear from you. Thanks so much, Tom and Judy, for everything you shared tonight. Like I mentioned earlier, there was a lot of positive feedback already in the chat window, so I know I'm not the only one that's saying thank you.
Thanks, Mike.
Okay, good night. Thanks a lot.
Good night, everybody.
Thanks again, everyone. We hope to see you back online next week. Have a great night.